We're group 12 and we're doing problem number 11.179, and the problem was the three-dimensional motion of a particle is defined by the relation r equals a parentheses 1 minus e to negative t which equals to a minus a e to negative t, and theta equals 2 pi t, and z equals b parentheses 1 minus e to negative t, which equals to b minus b e to negative t. First we found the first derivative for all three values, which gives us these numbers. So dr dt is equal to a e to negative t, the theta dt, that's a t, that's a theta, give us 2 pi, and dz dt give us b e to negative t. So it asks us to determine the magnitude of the velocity and acceleration when the part A t equals 0 and part B t equals infinity. So for t equals 0, that's the first derivative. So we plug in t. So we get a e to negative 0, which just gives us a. E to negative 0 just gives 1, so a times 1 is just a. 2 pi is just 2 pi. B e to negative 0 is just b. And for the second derivative, and we get the velocity by finding the square root of the sum of squares. So that would be a squared plus 2 pi squared plus b squared, and we take the square root. That would give us the acceleration, and that would give us the velocity. And for the acceleration, we plug in the second derivative. That would be these numbers, and we get negative a. That's the second derivative, and negative a e to negative 0 gives us negative a. 0 equals 0. Negative b e to negative 0 equals negative b. And we do the same thing for acceleration. We find the square root of the sum of squares. So that'd be negative a squared plus 0 squared plus negative b squared. And that's for part A. So for the second part, we just do the same thing, except this time we plug in t equals infinity. So when we plug in t equals infinity, we could bring the e to infinity to the bottom, which just give us 0. 2 pi is 2 pi. B e to negative infinity, just same thing. B over e to infinity will just give us 0. So that's for the velocity. You take the square root of the sum of squares. That's 0 squared plus 2 pi squared plus 0 squared, which just give us 2 pi. And for the acceleration, you take the second derivative and you plug in t infinity as t. And the same thing here, we get 0. Second derivative of 2 pi t is just 0, so 0 is just 0. And we get 0 for the last one as well. So we take this same thing, square root of the sum of squares, so that would be 0 squared plus 0 squared plus 0 squared, which is just 0. So the acceleration would just be 0. The velocity is 2 pi.